By expressing 1 in polar form and using Demois's theorem, find the solutions to z to the 5 equals 1 in polar form with argz between negative pi and pi. So what we have here is z to the 5 equals 1, which, as discussed in the previous examples, is cis 2n pi, where n is an integer. That means that z is going to be cis 2n pi divided by 5. So we have the n equals 0 situation. Let's call that one z1. That is cis 0. And of course, that's just 1. And we know that 1 would be a root of this equation. N equals 1 gives me what I'll call z2, which is cis 2 pi by 5. In degrees, that's 72 degrees. N equals 2 gives me z3, which is cis 4 pi by 5. Let's just putting n equals 2 in here. N equals negative 1 would give me what I'll call z4, which is cis negative 2 pi by 5. And n equals negative 2 would give me z5, which is cis negative 4 pi by 5. Any other values will be repeats, but note that z to the 5 equals 1 only has one real solution, but now that we're working in complex numbers, it has 5 solutions, as we would expect. Now we want to put them on the grid below, and note that each one of these rays is about 15 degrees. That means 60 degrees is about here. 135 degrees is around there. So cis 0 obviously goes just here. Now I said that 2 pi by 5 was about 72 degrees, and so that is going to be about there. And then we have one that's negative 2 pi by 5, so that's going to be down here. And then twice 72 is 144 degrees, so that's going to be just past the 135. So that's going to be somewhere around here. And then on the other side, we're going to get this one for the negative 4 pi by 5. They are equally spread. They are 72 degrees or 2 pi by 5 radians apart. It should be clear that the sum of these would be 0 just by looking at them as vectors. So the sum of all the roots would be 0.